At 13:47 hours in occupied Zaporizhia, 12 Ukrainian drones scream across a steel gray sky toward a Russian ammunition train at 97 km/h. The mission is surgical in its intent and merciless in its logic, a tightly choreographed strike designed to sever a single logistical artery and set back an offensive timetable. Down below in a reinforced shelter, operators watch 12 video feeds bloom to life, unaware that Russian counter-battery systems have already tasted the electromagnetic signature of their launch. The first 152mm shell lands 800mm away, a concussive punctuation that shakes dust from the bunker ceiling and turns conversation into practiced silence. The detonation is not a surprise detection came the moment 48 brushless motors powered up together, producing an electromagnetic spike that lit up direction-finding arrays like stadium lights. From the operator's cramped perspective, the choice is stark abort and live to fight another day, or press on under an incoming curtain of artillery. They choose the latter. The clock is unforgiving. They have roughly 12 minutes to reach the intercept point, and Russian guns need only a few minutes to reacquire and adjust. Above ground, a BTR-82A crew spots the tiny swarm and opens fire. Tracers arc through the morning air as the formation splits 4, high 4, low 4, straight through the middle, turning a single shape into 3 separate problems for any defender. Rounds tear through empty air. The drones are small, fast, and erratic. What the gunners cannot see is the thin fiber optic tether trailing from many of those drones, a fiber finer than fishing line, unspooling silently behind carbon frames, where the R-330 ZH and other jammers will flood the spectrum with kilowatts of noise. Those fibers carry light data pulses racing through glass that jamming cannot touch. The $10 million electronic warfare vehicle becomes an expensive paperweight against that simple glass thread. Still, Russian artillery had already found the operator's coordinates and began pounding the positions. The Ukrainians had prepared for this. They were not clustered in a single hole, but distributed across 3 separate bunkers, spaced 500 meters apart. That spacing is deliberate. A 152mm shell creates a lethal radius, roughly 300 meters. At 500-meter separation, a direct hit on one bunker would not necessarily incapacitate the others. The tactic accepts losses but preserves mission integrity. Even if 1 or 2 bunkers are suppressed, at least 8 drones should survive to finish the job. As the second round lands 600 meters away, the lead drone's camera resolves the target. Black diesel smoke coils from the locomotive. The convoy is approaching an exposed 2 kilometers straight, where the tracks run like a metal vein across open terrain, precisely the place where an attack would yield the most catastrophic logistic disruption. The Ukrainians had studied that line for weeks. This is the window they rehearsed for 97 seconds of exposure, in which defensive coverage thins and the geometry favors an asymmetrical assault. The third 152mm round impacts 450 meters away and changes the calculus. Shrapnel rocketing at roughly 1/500 severs 3 of the fiber optic lines clean through. Drones numbered 2, 5, and 8 lose their light-guided tether and switch to backup battery and radio control. Immediately, they become vulnerable to jamming. The remaining 9, with their fibers intact, continue to stream data through pulses of light at near-light speed, immune to the electromagnetic noise being poured into the sky. Inside Bunker 1, the operators make a quick, hard decision: continue while relocating. They grab their gear and sprint through a connecting tunnel to Bunker 4, 700 meters to the east. The 4th artillery round slams into the earth just meters behind where they stood seconds earlier. Their movement has bought them time. But 3 drones are now on radio backup and exposed to the electronic warfare environment centered on the rail junction. At 7 kilometers, the R-330 ZH detects the swarm and activates. 10 kilowatts of electromagnetic energy flood every frequency from 100 MHz to 2 GHz, enough to overwhelm every commercial drone control channel, GPS signal, and standard radio communication within a 30-kilometer bubble. The 3 radio-controlled drones go dark instantly. Their operator screens flicker to static. The other 9 still connected by fiber press on, with signals that remain impossibly clean on the operator's consoles. Inside the Jetel's command cabin, the operator watches his waterfall display fill with noise and wonders why those 9 threads still sing. He increases power sweep's frequencies from 2.4 GHz to 5.8 GHz, chokes every military band, nothing stops the light inside glass. The jamming now blankets friend and foe alike. A tragic irony, the BTR-82A crew at Checkpoint 9 can see the approaching swarm on thermal imaging, but is unable to radio the Pantsir S-1 3 kilometers away because the jamming silences their nets as well. The defenders have in effect blinded themselves while trying to blind the attacker. The train's engineer already warned in his brief about possible drone activity floors, the throttles. The heavy convoy accelerates from 42 to 48 to 52, finally topping 56 km/h, the limit for 4,000 tons on aging track. But every extra kilometer per hour shifts the intercept point further down the line. For every 1 km/h, the intercept moves 17, meaning the operators must continuously recalculate intercept vectors and burn precious battery life on course corrections. Battery is mission critical. Every microampere sacrifice to a correction shortens the window. At Checkpoint 9, the BTR gunner has exactly 8 seconds to engage the swarm as it crosses his engagement cone. Targets move at 27 ms, the size of dinner plates against the sky. He traverses Estimate's lead and opens the PKT machine gun, 800 rounds per minute. He attempts to walk fire onto the flight path, but the drones jink unpredictably up, down, left, right every 2 seconds like drunk hummingbirds. The geometry is unforgiving. By the time he aligns, the targets have already changed vectors. All his rounds miss. Radios remain dead. He cannot even call the missed shot to higher command. Thermal and electro-optical detection at the rail junction picks the swarm up again. The Pantsir S-1, designed to track cruise missiles and aircraft, initially filters the tiny drone signatures as ground clutter. The operator switches to electro-optical manual tracking, essentially a very expensive telescope with guns. At 200 malars, the system's twin 2A38M autocannons open fire, not at individual drones, but at the airspace itself. The gunner programs 30mm shells to airburst each round, programmed to detonate at a preset distance and fragment into hundreds of steel pieces, creating a wall of shrapnel. Drone 6 vanishes in an orange bloom at 900 meter. 3 seconds later, Drone 11 explodes. The surviving 7 scatter, 3 climb to 200 meters, 3 drop to grass height, 1 weaves laterally, and the gunner faces the classic trade-off of modern air defense: track the higher group against a plain background, or engage the nearest threat first. He chooses the high group, a choice that mirrors the mistake that cost another train 3 weeks prior. While the barrels move upward, the low group surges through and continues its path toward the target. On the ground at Observation Post 7, 40 Russian soldiers open a disciplined volume of fire with AK rifles. But at 27 ms, each drone spends only 0.74 seconds inside a soldier's sight picture at 200 malars. Human perception and trigger pull lag behind. Reaction time and the process of acquisition and aiming outpace the drone's crossing rendering. Small arms fire largely ineffective. Soldiers spray the air in synchronized bursts that in the end thinly populate the sky with wasted brass. 4 special drones executing a different vector, holding 500 meters altitude, dive toward the tracks behind the speeding train and release thermite charges. Thermite, a mixture that burns at roughly 2,500 degrees Celsius, is not an explosive, but an incendiary that melts rails. On impact, thermite eats through the steel like acid through paper. 4 sections of track dissolve into molten ribbons within seconds, creating immediate and permanent obstructions that make the line unusable. That damage will complicate any immediate repair and, more importantly, delays the resupply chain. Sustained fire can only run so long before physics intervenes. The Pantsir's barrels glow cherry red from continuous firing. Modern autocannons can maintain maximum rates for roughly 45 seconds before heat degrades, rifling rounds begin to tumble, and accuracy collapses. The gunner ceases fire to cool the system, a necessary pause that creates a 12-second window in which the sky is comparatively clear. 7 drones exploit that window and push through. Battery warnings flash orange on operator consoles. Drone 3, 18%, Drone 7, 21%. They need 30 more seconds to reach the train, but may only have 20 seconds of powered flight remaining. The pilots ration energy with military precision. Each correction, each evasive maneuver is a calculation of survival. Smoke from thermite-ignited grass fires drifts across the battlefield. Thermal imaging pierces fog and darkness, but carbon-laden smoke absorbs infrared across bands and degrades EO sensors. For crucial seconds, every Russian observation post loses visual contact. At 1/400 mmHz, the drone's cameras resolve individual details on the train cars, unit markings, rust patterns, and a white stencil on Wagon 22 reading Class 1.1 explosive. The fiber optic tethers approach their maximum designed extension. At 12,000 hours, a failsafe will release them to prevent tangling. The design uses a spring-loaded fishing reel-style mechanism engineered for reliable release. 10 seconds to release. 5, 3, 2. The first cable drops 13 mmHz short of optimal drone. One transitions to battery and radio backup with 8% power, remaining enough for perhaps 18 seconds if nothing goes wrong. The other cables follow in quick succession. Drones are now flying free and thus again vulnerable to jamming, but they are also irrevocably committed. From the cab, the train engineer watches 7 black dots grow larger. He slams the throttle beyond safety governors. The diesel engine's redline. Paradoxically, the harder he forces engine power, the less traction the driving wheels maintain. Once the wheels begin to slip, the coefficient of friction falls. The train loses speed despite the throttle. The engineer pours on power and watches as the train stubbornly loses ground. The Panzer tries a final engagement, but the drones have entered its minimum depression angle of 5 degrees and are now below its lower limit. $20 million of air defense technology is undone by simple trigonometry. At the final checkpoint, Russian soldiers fire every available weapon: machine guns. AKs improvise flak from RPG-7 blasts, but to hit the attacking drones, they would have to shoot through their own train. The attackers exploit the geometry perfectly, flying along the center line and using the bulk of the cargo as a shield against lateral fire. Drone 3's battery dies at 100 mmHz out. Its motor stalls and the props windmill uselessly. Momentum carries it forward at 97 km/h, and the operator had already accounted for this physical glide. The dead drone coasts on physics alone into the target zone. At 13:59, the lead drone impacts the coupling between locomotive and first wagon. The RPG-7 warhead detonates on contact. The shaped charge forms a jet of molten copper at about 2,800 ms, shearing the massive coupling pin instantly. 4 more impacts follow in deliberate sequence. Wagon 3's fuel valve assembly ruptures, spraying pressurized diesel. Wagon 7's brake line severs and locks wheels. Wagon 18, a thin-skinned ammunition car, takes a direct hit and initiates a chain of secondary explosions. Wagon 22's ventilation system is penetrated at 13:51:18, and inside its sealed volume, 12 tons of TOS-1A thermobaric rockets, already heating from vibration-damaged seals, cross an auto-ignition threshold at 447 degrees Celsius. The result is a catastrophic internal detonation. A pressure wave propagates, vaporizing car sections and setting off sympathetic detonations across adjacent wagons. Wagons 20 through 24 are effectively erased, vaporized into plasma in an instant. Wagons 25 through 47 are hurled off the rails, flipping end over end and strewing burning debris across the countryside. The blast produces a mushroom cloud that climbs roughly 1/400 mmHz in a destructive radius that extends far beyond initial estimations. In 4 seconds, a cadre of modified racing drones, low cost and relatively inexpensive, has removed a single rail link supporting 3 mechanized divisions and destroyed $127 million in materiel. The calculated cost of the attacking drones amounts to about $4,800. In strategic terms, the mission has severed a forward supply line and delayed a pending mechanized assault. But in the immediate aftermath, the strike does more than destroy steel and materiel. It ruptures tempo, command rhythm, and the illusion of control that logistics always promises. Across occupied Zaporizhzhia, radio nets flare with confusion. Field commanders demand updates from junction posts that no longer exist. The JTEL crew, deafened by their own jamming reboot systems, trying to reacquire signals that have turned into static ghosts. 30 kilometers north, a Russian repair battalion scrambles toward the coordinates with welding rigs and cranes, but they find the rails twisted like licorice and cratered so deep that every step rings hollow. The ballast beneath the tracks has liquefied into molten glass. The heat lingers in the soil-warping steel boots. A single Mi-8 helicopter circles overhead, its thermal sensors, painting a mosaic of white-hot debris that no machine can clear in hours or even days. Commanders radio to reroute trains through alternate spurs, but those spurs run closer to artillery range within the umbrella of HIMARS coverage. Every change in direction pulls fuel and time from the next operation. The ripple effect is immediate. An entire mechanized brigade scheduled to advance at dawn receives the order to stand down. The armor columns wait in tree lines, crews half asleep inside the cold hulls of T-72s, and BMPs listening to the distant rumble of explosions where the supply line used to hum. For the defenders on the ground, confusion turns into unease. The Panzer operators, having exhausted ammunition and fried circuits from overheating, are ordered to dismount and relocate, but the access roads are jammed with scorched freight cars. Artillery batteries deprived of shells that were supposed to arrive on that very train switch to ration fire one round every 15 minutes instead of full salvos. The sound of war itself changes from the steady rhythm of barrages to the hollow echo of sporadic detonations like a heartbeat losing tempo. Further east, in a command bunker near Melitopol, a colonel studies satellite imagery fed through encrypted fiber lines. The pictures show a serpentine scar of destruction slicing across kilometers of track. He doesn't need to zoom in to understand the magnitude. Every crater is a message written in the grammar of precision. This, he mutters to his staff, wasn't random. Intelligence officers begin combing intercepts, trying to trace how the Ukrainians managed to circumvent jamming so completely. Analysts pull up spectrograms of the electromagnetic environment recorded just before the strike. What they see makes little sense: clean signal lines in a field of noise, as if light itself had learned to whisper through chaos. The colonel exhales slowly. He knows what that means. This wasn't just luck. It was a demonstration. By evening, Russian state channels report sabotage activity without mentioning drones. The story shifts toward track maintenance errors and spontaneous fuel explosions. But on encrypted channels between field units, the story spreads differently. Rumors of drones immune to jamming, ghosts flying on wires of light impossible to intercept. Fear takes root not in soldiers, but in technicians, the men who must stand next to equipment that suddenly feels obsolete. On the Ukrainian side, reconnaissance satellites pick up the growing grid of fires where the train had been. The operators receive confirmation: target neutralized, area impassable. The mission is logged as complete, yet none of them speak. The bunker hums with the sound of cooling fans and exhausted silence. Above them, the night sky over Zaporizhia glows faintly orange, marking the place where technology and human will intersected, and the laws of physics briefly chose sides. When the smoke clears, the calculus of the battlefield has shifted. For the operators, a mix of exhaustion and quiet satisfaction replaces adrenaline. They have executed an operation grounded in precise timing, redundancy, and the exploitation of physics as much as technology. For the defenders, the after-action will be a catalog of how tools designed for one generation of war struggle against tactical ingenuity. For the frontline units dependent on that rail line, the assault is an immediate logistical blow that will ripple through plans and timetables. This engagement is not an illustration of overwhelming force, but of adaptation. A modest fleet of unmanned systems linked by a simple fiber and guided by human judgment outmaneuvered expensive electronic warfare and layered air defense through a combination of stealth timing and engineering simplicity. It is a reminder that in modern conflict, asymmetric innovation can turn a single hour of the battlefield into an irreversible strategic setback.